Good morning, students. You have experienced one sessions of physics and chemistry through the online resources we are having. And my request to you to all is, whatever the resources we are having, the teachers are putting all the effort to get you the maximum benefit. So the same can be achieved only when you, the students, make it sure that you will work according to the potential, and let us hope that the beginning of this academic year will put all your last year's difficulties aside, and we should start in a better way. And at the same time, we can hope that we will meet personally, means we will come back to our live class section at the earliest, and let us pray to the Almighty that this pandemic will come to an end at the earliest. Okay, so let us go to the business. So we know in mathematics it's not necessary to start all the chapters in a definite order, and especially because of the convenience of taking the class as online, I just prefer to start with the chapter Matrices. Actually, Matrices is the third chapter. And when we come to the introduction, these matrices belong to the linear algebra section of mathematics. Actually, in the lower standard, we are quite familiar with algebra, arithmetic, geometry, etc. And actually, in the algebra itself, when we come to the higher classes, there is a particular section known as linear algebra. And it is having a lot of practical applications also. So anyhow, we come to matrices. So first of all, we have to make out what is meant by a matrix. And actually anyhow, we know that our approach to the classes and the studies is mainly on the examination point of view, and because of your fortune, there will be no theory question, means there will be no question of definition, derivation, etc. in the board examination. But then also it is better clear the definition, the terms, the concepts as much possible. Okay, and not necessary to dictate the notes for these definitions, etc. Okay, so first of all, we come to what is meant by a matrix. Okay, the name of the chapter is Matrices. Then actually the singular is matrix. Okay, matrix is the singular and its plural, that is matrices. Okay, then we have to make out what is meant by a matrix. So we simply say a matrix is an arrangement. What is matrix? It is an arrangement. And this arrangement term, it is more mathematically or classically also said as array. So array means arrangement. So what is matrix? It is an arrangement. Then thereafter, the question arising in our mind is an arrangement of what? Okay, we can say it is an arrangement of numbers. So matrix is an arrangement of what? Numbers. Then the question arising is what kind of arrangement? Because when we do the arrangement, for example, we have some students, they are to be arranged, okay, we can arrange them in a circular manner, we can arrange them in a line, we can arrange them in L shape, any shape. Okay, so here the question arising now is what kind of arrangement? Okay, and the answer to that question is this is a rectangular arrangement. So what is the shape of the arrangement? Rectangular. Okay, and when we come to rectangular, the term comes to our mind is rectangle. Okay, and the lower standard we studied that a rectangle has two dimensions, namely the length and the breadth. So this rectangular arrangement is also having that similar concept, namely what? Length and breadth. So lengthwise arrangement, and practically we saw such arrangement as what? A row. And the breadthwise arrangement, practically we call this arrangement as a column. We have defined a matrix. So we said a matrix is a rectangular array of numbers arranged into rows and columns. And one more thing to remember here is we said it's an arrangement of numbers. Okay, and already we are familiar with two types of numbers, namely real numbers and complex numbers. So the numbers can be either real or complex, or sometimes it is a combination or a mixture of real and complex numbers. But usually here in our syllabus we are dealing with a matrix containing real numbers. So anyhow, what we simply said, matrix is an arrangement of numbers. Okay, and these numbers are known as the elements or the entries. Okay, these numbers are known as the elements of the matrix or the entry or entries of the matrix. Okay, now related to matrix, we come to what is meant by order of a matrix. See, in the very definition, we said in the definition of matrix, there is a concept of a rectangle, because it is a rectangular arrangement of numbers arranged into rows and columns. Okay, so there is a concept of rectangle, and we know that when we come to a rectangle, we specify the rectangle by mentioning its dimension. For example, if you consider a rectangle of length 3 and breadth 2, we say the rectangle is 3 by 2. We write it as 3 into 2, but as it is a dimension, we read it as what? 3 by 2. It means the rectangle is of length 3 unit and breadth 2 unit. In the same manner, we come to what is meant by the dimension of a matrix. But dimension, the term, when it comes to matrix, we say it more classically as order of a matrix. Okay, then for that we consider an example. Okay, then when we come to example, just we recall what we studied in set theory. In set theory, we saw that the sets can be named or represented by capital alphabets of English. In the same manner, for naming a matrix, we make use of capital alphabets. Okay, suppose we consider matrix A. So this A is the name for a matrix. Actually, we know a name is a convenient way to represent something, and here capital A represents a matrix. Okay, but according to definition, what is matrix A? It's an arrangement. Okay, and that arrangement is to be enclosed in a symbol. Then the symbol we are using is square bracket. Okay, then the arrangement contains numbers. Numbers are arranged into what? Rows and columns. So we can go for any numbers. For example, 1, 2, 3. -1, 4, 5. 3, 2, 1. 6, 7, 0. Okay. So this is a matrix. Okay. Then, according to the definition, we know that the arrangement is made up of two types of arrangement: horizontal arrangement known as rows, vertical arrangement known as columns. So we can make out how many horizontal arrangement: 1, 2, 3, 4. The meaning is what? In this matrix A, number of rows is equal to how many? 4. And the vertical arrangement, that is columns, number of columns is equal to 3. Okay, so like a rectangle, we came to the number of rows and the number of columns of a matrix. Okay, now we say, and this is the mere definition, so there is no question how does it come. It's a mere definition. So we say order of the matrix A is equal to how many rows? Write it there, 4. Then by how many columns? 3. That is 4 by 3. Okay, and symbolically we can say order means O of the matrix A is equal to 4 by 3. Okay, so the simple meaning is what? For writing the order of a matrix, what we need? The number of rows and the number of columns. And it is very important to remember that while writing the order, which number is to be written first? Number of rows, then number of columns. Okay, so in general, what we say, if a matrix has m number of rows and n number of columns, then the order of that matrix is order of A is equal to m by n. And always remember, just like the dimension of a rectangle, the order of matrix, when we write as m into n, but we read as m by n. Okay, and the other thing to remember is, when we write a matrix, oftenly at the right bottom of the matrix. Okay, this is the right bottom, and here we write the order also. For example, here we write 4 by 3. So it says that A is a matrix of order 4 by 3. Clear? So we have discussed what is meant by, now one more thing. Look, we said it's a rectangle of order 3 by 2. Length is 3, breadth is 2. So 3 by 2, and if you do the actual multiplication, that is 3 into 2, 6. Actually, what does it give? It gives nothing but the area of the rectangle. 6 square unit. The meaning is what? From that rectangle, we can make small 6 squares. In the same manner, look at here, 4 3s are 12. What does it mean? This matrix contains what? 12 elements. 3, 6, 9, 12. Okay? So, the order is directly related to the number of elements of the matrix. Okay. Now, we come to how to write a matrix of any order. For example, we have written matrix of order 4 by 3, we can write matrix of order 3 by 2, matrix of order 5 by 4. In general, how to write a matrix of order m by n? The meaning is what? Matrix has, the meaning is, look, A is a matrix, okay, and this matrix is of order m by n. How to write it? Okay, so we come to Okay. Then the meaning is we have to write a matrix containing m rows and n columns. Okay, we write to the and one more thing, when we come to a matrix, every element belongs to a particular row and a particular column. Okay, for example, an element belongs to the third row and second column. Okay, then matrix is denoted by capital alphabet and usually elements are denoted by small alphabets. And if the name of the matrix is capital A, then the name of an element should be small a. Okay, but the matrix has many elements. Suppose we are writing the element belonging to the third row, then 3 and second column 2. So we write as what? A32. Okay, so in the same manner, look at here, we are writing the first element. First element means it is very clear this element belongs to the first row, first column. So it is A. First row means 1, first column means 1. A11. Now we write the element here. It belongs to which row? First row, second column. A12. Then first row, third column. This way we come to the last element of the first row. Okay, so we are writing even the last element of the first row comes to the first row, so it is 1. Okay, and it comes to which column? The last column, first column, second column, third column. That way the number of columns is n. The last column is the nth column, that is A1n. Okay, then the same manner second one is now clear. A21, A22, A23, etc. A2n. Okay, this way we write the third, fourth, etc. No need to write the elements. Okay, so first row, second row, third row. Now we are writing which one? The last row. Okay, first row means 1, second row means 2, third row means A31. So the last row, how many rows total? M. So AM1. Then AM2, AM3, etc. We come to the last column, that is AMN. Okay, so this is the way to write a matrix of order m by n, and we can simply say this is the way to write a matrix in the general form. Okay, so now the same matrix, this matrix can be written in the symbol form. Okay, symbol form means, look, A is a matrix, put the matrix symbol, then we said the elements of capital A can be represented by small a, then A11, A12, A13, etc. So here, for example, this is what? A23. What does it mean? This is the element of the matrix A which belongs to the second row, third column. So in general, here we write the element A. Okay, but we are writing all the m by n elements. Okay, so the meaning is whatever the element, actually the simple meaning is here we are representing a variable element. That variable element covers or contains all the elements by making some changes. Okay, and here in the suffix, okay, this element definitely belongs to a particular row. Suppose that row is the ith row. It belongs to a particular column. Suppose it belongs to the jth column. So we have written A equal to matrix Aij. Look, if only this much is written, what does it mean? This is a matrix containing only one element. But we said we are not writing a matrix containing only one element. We are writing the matrix containing mn elements, or we are writing the matrix of order m by n. So further we have to write, okay, Aij, where, look, what is I? I is the row number. If it is in the first row, it will come as what? I is 1. If the element is in the second row, then I is 2. So the meaning is, we can say where I is equal to 1, 2, 3, etc. Total how many rows? There are m rows. Okay, and j is equal to 1, 2, 3, etc. n. If this is also written, then it is very clear what this is not a matrix containing only one element. Otherwise, Aij is not representing a single element, but represents what? Many elements. Actually, it represents how many elements? M into n, mn elements. And if you want to obtain a particular element, then what to be done? Replacing the row number I and the column number j with the position of that particular element. Okay, so this way we can come to which one? A matrix of any order. Okay, then hereafter we have to come to classification of matrices. Okay, and the classification of matrices, I think it is better we do in the next session. So as a start, it is better just we start in small doses. Okay.